So, hi everyone. So, we're going to present our project based on our paper Immortal Certificates on Ethereum blockchain by Aisha Lali, Leandro Maciel, and Aspen Olmsted. Our outline will consist of problem statement, methodology, implementation, design, demonstration, and conclusion and future direction.
Diploma verification is crucial in today's job market, but faces challenges such as fraud and inefficiency. Problems with conventional methods are slowness, they're expensive, and prone to forgery. Our solution is a blockchain-based system designed to improve security, efficiency, and transparency. The benefits are immutable records that cannot be altered, decentralized enhanced security with no single point of control, and it's cryptographically secure, ensuring authenticity and integrity of the data. Our proof of concept aims to reduce verification time and costs, enhance trust, and minimize forgery risk. Overall, a blockchain-based solution to address traditional verification problems, offering a secure, efficient, and transparent system.
Hi, Asha, do you want me to go over this part?
Yeah.
Yeah, so basically, we decided to use Ethereum blockchain. It is a reputable blockchain, very strong, billions of equivalent dollars in ethers, very, very strong. And the concept is using a non-fungible token contract, a smart contract, with a voting mechanism to make sure the universities or the certification issuers will be able to enter in the system through a proof of stake, kind of. We had several discussions, but since we are using the Ethereum, we decided to use the Sepolia testnet because we don't want to start using ethers for the test. So we use just a test net. The IPFS is the interplanetary file system, is a way to reduce the load on the blockchain, offloading the blockchain and having the diplomas per se, the pictures or the PDFs in the IPFS outside the blockchain. So that reduces also the use of ethers, which is the currency or the gas for the smart contract. And finally, we use the Remix, which is the IDE. It's a web-based with the language Solidity, which is the language that is pretty much the standard for Ethereum smart contracts. Another option is to use the Truffle Ganache, but we prefer to use a web-based because that reduces the cost, and Remix is very, very good. So next slide. So here is just a very simple diagram of how we implemented. And I mentioned the Solidity, the Remix. We use MetaMask as the wallet, Sepolia, the testnet, as we mentioned before. The Ether scan is just a way to validate the use of gas. It's just, it shows how much you're using per transaction. And in fact, Ether scan is a very good tool for all the Ethereum network. And then finally, Pinata we use for the decentralized storage of the IPFS. Again, in our paper, if you read, we have some questions about using Pinata. We might use, as we progress in future work, a different IPFS system. And here is just a little diagram that we go with a Remix, which is the IDE. We write contract. We use MetaMask and Sepolia as the wallet and the testnet in Ethereum. We write the smart contract in Ethereum, and then you upload the diploma through the IPFS using Pinata in a JSON file. So that's the way we create the diploma into the blockchain. Next slide. Now, for the verification, once the diploma is already in the Ethereum blockchain, then how can we check if the diploma is there? How can we check that it's functioning? So you see the front end, Aisha is going to present later. We have a student verification portal, so we enter the data. We use OpenSea basically to access the Ethereum and to see the diploma. It's just an application, be anything. And then we enter in the blockchain and the diploma comes out. So it's very simple and we verified. There's going to be a video we show about the prototype working and we can see how we did this. Okay, next slide.
Okay, so in this section, I'll be walking you through the core design of our Immortal certificate system, highlighting how we ensure the security, integrity, and perpetuity of digital diplomas, which is our main goal from creating this project. I'll be covering the key components of our design, including the processes for authorizing institutions, issuing diplomas, and verifying their authenticity. This flowchart outlines the process that institutions must follow to become authorized issuers of diplomas within the Immortal certificate system. It details the steps involved from initiating a request to receiving authorization. The main menu has 3 options: requesting to become an issuer, issuing a diploma, and verifying diploma. This flowchart, we focused on the first option, request to becoming an issuer. Initially, the institution requests authorization to issue diplomas. This step is critical to ensure that only legitimate and vetted institutions are part of the system. The system checks if the request fee submitted by the institution is sufficient. This fee acts as a barrier against spam and ensures that only serious requests are processed. If the fee is sufficient, the system then checks whether the institution is already authorized or if there is an active cooldown period in place. The cooldown period is a security measure to prevent frequent reapplication by the same institution or wallet. If the institution is already authorized or the cooldown is active, the process ends and no further action is taken. If the institution is not yet authorized and there is no cooldown period, the system proceeds to submit the issuer request and increment the pending request for that institution so that they cannot re-request. There's a cooldown period. So you might be asking, what if the existing universities do not participate in voting as expected? The flowchart we saw that there is a fee that is paid by the new institutions. We use this fee as an incentive for existing university participation. The funds gathered by each request is distributed onto the institutions that voted. We do not expect every participating institution to cast a vote for each new request. We initially set the request approval rate to be at 70%, although with large enough pool of institutions, this could be reduced further. Voting also allows institutions to vet issuers they deem authentic and reputable. All of this ensures that a decentralized and democratic process maintaining a high level of security and trust in the certification process. The second option in the main menu is to issue a diploma. If issuing a diploma, the system first checks the caller if is an authorized issuer. If the user is authorized, the diploma is minted and the URI is set. If the user is not authorized, the process ends. Initially, we thought of mandating voting for each institution before they can submit to issue a diploma. However, this could become a burden, and we concluded that monetary incentive to vote would be better. You might be wondering why an institution would join this network, considering the cost involved in using Ethereum to upload diplomas to the blockchain. Students have to pay for requesting a diploma already. Some charge up to 60 euros. Plus, this requested diploma could be lost by the student and have to be reordered later. With Immortal certificates, both the institution and the student benefit. Once a student requests a verified certificate, a fee is collected and paid in full to the issuing institution. This allows the institution to pay for the cost of issuing the certificate and leave room for some profit. The student in return only needs this single diploma, which would last a lifetime. In the third option in the main menu, we are verifying a diploma. In this scenario, the student gives his or her diploma token to a prospective employer or interested party, and this token could be verified using the Immortal certificate smart contract. The system retrieves the details of the diploma. The system checks if the diploma taken exists on the blockchain. If the token does not exist, the process ends. And if it does exist, the system returns a detail of the requested diploma, confirming its authenticity. This process ensures that only legitimate and existing diploma tokens are verified, maintaining the integrity of the system.
In this short video, we present a test run of an Ethereum blockchain application designed to store university diplomas in a decentralized and immutable manner. The front-end page offers 3 basic functions. Let's begin by requesting authorization to become a university that can issue diplomas. First, we enter the institution's official name and an identification number or nickname, referred to as the institution ID. Since we are utilizing the Ethereum blockchain platform via this smart contract deployed in an Ethereum virtual machine, we need to use some gas to pay for the transaction. Next, we go to the machine that deployed the smart contract and see the pending request awaiting approval. This system is designed to have a decentralized approval mechanism based on a proof-of-stake concept, involving existing universities in the system. The approval process also requires gas ethers. Now, let's issue a diploma. The required fields are presented and can be customized. For the sake of time, we show the issue diploma field already filled in. It is crucial to avoid errors in these fields, since they will be stored in the Ethereum block as metadata. As observed, issuing a diploma requires about 0.009 ethers. Diploma issued successfully. The token ID is 0. To test, we will retrieve the token ID 0. The diploma is correct, including the metadata. We can verify that the university is an authorized issuer by clicking the Request Authorization button. There are no pending requests. Entering a new student with a new diploma follows the same process. The diploma itself, a picture in PNG format, is not stored in the block to save gas and avoid overloading the chain. Instead, the picture is stored on a decentralized Level 2 storage using IPFS technology. In this case, the gas cost was about 0.005 ethers, varying depending on the time of day. We inadvertently issued the diploma ID 0 twice, making token ID 0 and token ID 1 identical. The new student has a token ID 2. To verify if token ID 2 was properly stored in the blockchain, we use the retrieve diploma function. And there it is. Note that any kind of diploma, even an online survey certificate, can be stored. To confirm that tokens 0, 1, and 2 were properly stored in the Ethereum blockchain, we go to another machine, different IP address, different Ethereum account, different Ethereum wallet, to validate the system using the smart contract stored in the Ethereum blockchain. We can see that retrieving a diploma does not require using gas ethers and that the 3 tokens were successfully retrieved. As future work and improvement ideas, the system could verify if redundant diplomas are stored to avoid unnecessary storage. Note that one student could have the same metadata, name, ID, etc., and more than one diploma, with the image being distinguished by the token ID. Our diploma system works as an NFT, non-fungible token. This concludes our test run. More information can be found in the documentation.
So for our conclusion and future work, this project successfully demonstrated the feasibility of blockchain technology for enhancing diploma verification. emphasizing security, efficiency, and transparency. By utilizing smart contract for issuance and verification along with IPFS for secure off-chain storage, the system provided a robust has the potential to provide a robust alternative to traditional methods, ensuring the confidentiality, integrity, and availability of diploma records. Moving forward, the project will focus on security enhancements, strengthening the system with secure by design principles, incorporating quantum-resistant encryption, and rigorously testing against common vulnerabilities such as reentrancy, arithmetic errors, and front-running attacks, among others. Another thing we're considering is resilient IPFS storage, developing a backup system for IPFS managed by willing institutions to create this backup, making it more difficult to delete or tamper with IPFS content. Since IPFS, there is integrity in the certificates, however, there might be data might be deleted from IPFS, so there is that risk, and so that's why we're thinking of having the institutions get some incentive to have backups. Also adding capabilities for institutions to research for diplomas. So let's say a student forgets their token ID, the institution should have the ability to look through its certificates through the student name or ID. And also we want to work on streamlining verification process, refining the system performance, using user feedback, and exploring additional features and an optimization, especially in terms of gas. We want to find ways to reduce the amount of gas needed to do to upload and use the system, and also increase. We aim to introduce this once it's done to participating institutions. We hope that will participate in it. And thank you so much for listening.
Thank you, guys. Any questions for them? Okay. Thank you, guys. I think.
I'm sorry, cut off.
I think we're done.
Okay.
Any questions?
Sorry, Professor Olmsted, we couldn't hear you.
Oh, can you hear me now?
Yes, better.
Yeah. Oh, okay. Sorry. Yeah, you guys are great. Any questions for them? No, quiet audience. Thank you, guys.
Thank you.
Nosi, you want to share your screen? Go next.